Hi everybody, in this video we're going to be talking about order of operations, which is unit 9.4.1. So order of operations just gives us a particular way for us to go about solving our problems, so that way we will have a common answer at the end. And so we just have these operations, like we might have addition, subtraction, multiplication, division. We're going to have exponents. We could put some square roots in there. We could do fraction bars, and they cause us to group our terms certain ways. And as long as we are all following a common order, which is what we're going to talk about here, then we all end up with the same answer. And so let's start talking about what we do first. And we're also going to review some terms because we haven't talked too much about exponents or exponential notation yet. So that's why we're going to go through a few of those terms first. So exponents are used to represent repeated multiplication. So for example, if you had something like this, 5 to the third, if like on the very basic calculator I have, I can put that in my calculator and I can do 5, and then I think it's y to the x, I think is the button. So I'd hit 5 and then the y to the x button, and then I would hit 3, and then I would get out 125 for my answer. Well, what I'm telling my calculator to do, or what my calculator is doing when I put that in there, it's doing repeated multiplication. It's saying I have 3 5s that I am multiplying. And so 5 times 5 is 25, and 25 times 5 gives us 125. And so that's what exponential notation is doing. And so even if we had something like this, if we had x squared y to the third maybe, we would actually expand that out to say x times y times y times y, because we have 2 x's and 3 y's, and they're all being multiplied together. So that's what exponential notation is. It's just a way for us to condense, like writing this out every single time would take up some space and it'd be kind of, challenging to write out that many x's and y's several times. And so exponential notation is a way to kind of condense that written form, and it tells us that we are doing that repeated multiplication process. So our exponential notation, we have one term called base, which is the number or expression that's being raised to a power. So if we have something, I'm going to just take my example from up above. If I have 5 to the third, the base is going to be the 5. I also think about like cheerleading. Cheerleading, the bases are the people that are on the bottom and they're raising up the little flyers, or so I'm told. But so the 5 would be the base. And then the 3 is going to be the exponent. And the exponent is the number or power that the base is being raised to. So it's going to be the little number. You might also see it like this. And so in this case, the xy would be the base. And then the 3 over here would be the exponent. So here we're just going to practice evaluating the following exponents. So if we have something like this, 3 to the third, that's not 9. I often will get the answer, well, that's 9. No, that's not 9, because we're doing 3 times 3 times 3. So 3 times 3 is 9, but 9 times 3 is 27. And again, you can put that in your calculator. You can do 3 to the third. All of your calculators should be able to do that function of 3 to the third. And then let's say we've got 3 to the third times, what are we going to do? 3 squared. 3 squared times 2 to the third is what we're doing. All right, so let's do this part first, and then we're going to do this part. So 3 squared is going to give me 9, because 3 times 3 is 9. 2 cubed, 2 to the third power. 2 times 2 is 4. 4 times 2 is 8. 9 times 8 is 72. And that gives you 72. All right, so let's talk about grouping symbols. Grouping symbols include parentheses, which is what we saw with the associative property. Parentheses. And then we've got brackets. And I know that kind of looks almost like a rectangle. A bracket's going to look like that. Bracket. Braces. the curly Q ones that look kind of like that. We've got absolute value bars. So we talked about absolute value, stuff like we did the absolute value of -10, that would be 10. And even fraction bars. And some of you might be thinking, what? How can fraction bars be a grouping symbol? Well, we might have something like let's say we had 2 squared plus 3 times 4, and then we had that all over -4 squared minus 1. So in that case, the fraction bar would work as a grouping symbol because we're going to do everything in the numerator first. Then we're going to do everything in the denominator, and then we would simplify. Grouping symbols are often used to clarify which operation to do first. If there is an expression to be simplified within a grouping symbol, then follow the order of operations within the grouping symbols first, and then work your way out. So what that's telling you is like if we've got -2 plus 1, and then we've got 4 squared minus 3 times 2. What that's saying is within the grouping symbol, do this stuff first, do the 4 squared, then the multiplication, then subtract, then multiply, then add. So you'd work from the inside out for that. All right, order of operations. Operations can include exponents, roots, and again, roots are like the square root of 16 would equal 4. Or if we were doing the cubed root of 8, that's like what number times itself 3 times would give me 8? Well, we did it up above, it was 2. It was right here. Your calculator can also do this. You can find the third root of a number. So your calculator should have that button on there. But anyway, that's what the roots are talking about. So any type of root, squared root, a cubed root, a fourth root, a fifth root. So roots. It could be multiplication. It could be division. I'm running out of room. It could be addition and subtraction. Perform all operations. So here's our steps. We're going to perform all operations within grouping symbols first. Then we are going to evaluate exponents or roots, and they're kind of on the same level. So we would evaluate exponents and roots from left to right, and then we are going to multiply or divide whichever comes first from left to right. That is so important. I feel like that has either gotten taught wrong or missed in math classes in your past, but you are doing whichever one comes first from left to right. So oftentimes I've seen, and we're going to write it down below, but that acronym of PEMDAS. And because the M comes before the D, people are like, oh, you always multiply before you divide. Well, that's not necessarily true. So let me actually make this a 12. And then I'm going to make this a 4. And then we're going to do times 3. So oftentimes what I see, so like in this very example, people will go, oh, I'm going to do 4 times 3 because I multiply first and then I divide because the M comes first. That's not true. You go from left to right in the expression. So let's say we did it wrong. This is the wrong way to do it. So we would do 12 divided by 12, and that gives me 1. Okay, that's wrong. We're not going to do it that way. We are going to multiply or divide whichever comes first from left to right. Well, the one that came first was division. So I'm going to divide first. So 12 divided by 4 gives me 3. And then I still have times 3 here at the end. 3 times 3 is 9. See how you get the totally wrong answer if you do the operations wrong? 1 versus 9. 1 is wrong, 9 is correct. So be careful on that. That's something you have to watch out for today. And then same thing, we're going to add or subtract from left to right. Whichever one comes first, from left to right. To help remember the steps, you can also use the acronym PEMDAS. Because the P here would be your parentheses or your grouping symbols, but that I've also heard people call it GEMDAS or GEMDAS because it should be grouping symbols, not just parentheses. And then it's exponents, and then it's multiplication, and then it's division. But again, that's from left to right. And same thing with addition, subtraction. It's from left to right. So be careful on that. So please, when we're doing our please excuse, we're just going to fill that in parentheses. Exponents and roots. See how this acronym misses some of these operations? So I don't love it, but oh well. My dear, which is multiplication and division, whichever one comes what? First. So important. That's why we're writing it again. Aunt Sally, addition and subtraction, whichever one comes first from left to right. All right, and then we're going to do a ton of examples. So example number 1. We have got 3 times 1/3 minus 8 divided by 1/4. And yes, I know it's possible for you to put this in your calculator. It's just going to come up with the answer, but you're not going to get any points for just providing an answer. You've got to show your work. So if it's helpful, write out the acronym at the top. There's no parentheses. There's no exponents. We do have multiplication and division go from left to right. So if I'm going from left to right, I'm going to multiply first. I'm going to divide second. And then I'm going to subtract third. That's our order going across here. So 1/3 of 3. You can either say, well, that's 1, or you can do 3 over 3, which is 1. And then we're going to subtract, and we keep, we change, we flip. We keep, we change, we flip. So then we end up getting 1 minus 32, which gives us a negative 31 for our answer. All right, let's try another one. We've got 2/3 times 3/2 squared plus 1/4 cubed times, where am I at? I lost my place, times 32. And again, if you need to, come back up here. Do we have parentheses? Yes. Look inside any of them. Can we simplify anything within any of the parentheses? No. Now look at exponents. We have exponents. We've got some exponents here and here. Let's take care of that. So we're going to do 2/3. 3/2 squared. We haven't worked with exponents a ton. So 3/2 squared, I'm going to take a moment. We're going to do, that's 3/2 times 3/2. So 3 times 3 is 9. 2 times 2 is 4, and we're going to get that. Plus, and again, this 1/4 cubed is going to be 1/4 times 1/4 times 1/4. 1 times 1 times 1 is 1. 4 times 4 is 16. 16 times 4 is going to give you 64. And then times 32, I'm going to put it over 1 because I know I'm getting ready to multiply it by a fraction right here. Okay, and I want to back up for a second because I get the question of, can't I just cross these off like 2/3 and 3/2? Well, why can't I? Why can't I just cross them off? Because that would be me doing multiplication before my exponents, which is not allowed. I've got to do my exponents first. All right, now I have taken care of parentheses, exponents. Now I'm ready to do my multiplication. I don't have any division, and then I'll do my addition. All right, I'm also going to simplify here. You guys, if you wanted to, could also do multiply across, and you're going to get 18/12 and then reduce. I'm going to reduce here. So that's going to be a 1. That's going to be a 3. This is going to be a 1. That's going to be a 2. So then I get 3 halves. And then here, that's going to be a 1. That's going to be a 2. Or it's going to be 32 over 64, which is 1/2. So I'm going to have plus 1/2. Oops, I almost wrote 1/4. Oh, I can make that a 2. 1/2. And then we're going to get 4 halves, which results in 2. That worked out nicely. All right, let's try another one. We've got -14 plus 3 quantity squared plus 8 divided by 2 times 4. All right, you should pause the video and see if you can do this one on your own and see how you do. And then I'm going to work through it. So here we've got, again, parentheses. Let's work inside here first. -14 plus 3 is going to give us -11. And then we're squaring it. And then I'm going to write plus 8 divided by 2 times 4. Next one is exponents. I'm going to take care of that -11 squared. I want to show you something. This is something that's commonly missed because I'm going to show you there's a difference. This versus this. They're different. One ends up being positive, one ends up being negative. So this one says you're going to take that entire quantity of -11 and you're squaring it. So you're doing -11 times -11. This one on the right, it is saying essentially like this. You could peel that negative off if you wanted to help you see it better. And you can write -1 times 11 squared. And so it's only squaring the 11. So it's going to be -1 times 11 times 11. So this one, negative times a negative, ends up giving us a positive 121. This one is going to end up giving us a negative 121. So that's something to like beware. Beware of this scenario. What we have is the first one. But that's one for you to kind of keep an eye out for. All right. So -11 squared, we've got 121. Remember, multiply, divide from left to right. So I'm going to take care of that division too. So then I'm going to have plus 4 times 4. Now, which one do I do first? Do I add the 121 and 4? No, I multiply first. So do this part next. And if it helps you, I've had students to just like go through and just put parentheses around their next step like that. That's great. That helps really like make it visible for what you're doing. So then we're going to do 121 plus 16. And now we're ready to finish off with that last step of 121 plus 16. So that's going to give us 137 for our final answer. Okay, let's try another one. So number 4, I've got 1.5, the quantity of 1.5 plus 3.5. End of parentheses, minus 2 times the quantity of 0.5 times 7, times 7, and then we're squaring it. All right, so go back, follow your PEMDAS that I've now kind of covered up. Do we have parentheses? Yes, let's do that. So we're gonna do parentheses and parentheses. 1.5 plus 3.5 is gonna give us 5. And then we've got minus 2. What's half of 7? Half of 7 is 3.5. So we're going to do, 5 minus 2, and then it's going to be 3.5 squared. And what I might do, 3 and 1/2, that's going to be 7 halves. I'm going to write it like that. You can totally do this in your calculator if you prefer. We've got 5 minus 2, and I'm thinking about how I'm squaring this. And so I've got 49 over 4. Let me see what you guys get as a decimal in case you're doing it that way. You should be getting 12.25. So that's, I'm just going to write that. You could also be getting 12.25. And then for me, that's doing a fraction. Then I'm taking this 2, and that becomes a 2. And then here, I'm essentially saying, well, what is half of 49? So we're, half of 50 is going to be 25. So then our half of 49 is going to be 24.5. Or you could do like 24 and 1/2, or you could leave it, you could do your 49 over 2 if you wanted to leave it as 49 over 2. But anyway, or you can do your, what did we have? We had 12.25 times 2. So you could do your 5 minus, I don't know why I just did that, because that's going to be 24.5. All right, and then you're finally ready to subtract those two. And so again, you can think about it in terms of, I mean, you could either do it in your calculator, you could say, what's 24.5 minus 5? And what should you end up getting? And our final answer for that one is going to be negative 19 and 1/2, or you could do negative 19.5. Either way. Okay, let's do number 5. Sorry, I kind of jumbled my way through that one. Getting distracted here with my surroundings. All right, number 5. We've got, let me find it. All right, we've got 5 and 1/2. 5 and 1/2 minus the quantity of, we've got brackets this time, quantity of 3 plus yet another set of parentheses, 2 times another set of parentheses, a negative 6. And then we're going to close that bracket as well. And then that's going to be all over negative 3 squared plus 2. All right, so let's figure out our first step. We've got lots of nesting parentheses. We've got a fraction bar as well. So I know this can look overwhelming. Let's just start with one step at a time. So within, oh my goodness, within our brackets, we've got a brackets here. And then let's work within this set of parentheses. This set of parentheses in here is just showing us that we have a negative. And so it's saying we're going to take 2 times negative 6. So this 2 times the negative 6 is going to give us a negative 12. So I'm going to rewrite this so it looks a little bit better. And we're going to do 5 and 1/2 minus the quantity of 3. And then we have plus a negative. So if you want, you can write that, or you could just write minus 12. So right now that's what we have all over. And let's take care of one step in the denominator. Here is this situation. We've got the negative and then the 3, and we're squaring it. Which one of these is it? Scenario 1, scenario 2. It should be scenario 2. So look at our answer. It should end up being negative. So this should be negative 9 plus 2. This is one. I can't tell you how often it happens. Students will plug it in their calculator. Negative 3 squared. Liz, I'm getting positive 9. That's because your calculator, you are telling your calculator to go like this. Negative 3 times negative 3. And so your calculator is doing that, and it's getting a positive 9. That's not what that's asking us to do. This, again, is asking us to go like this. Negative 1 times 3 times 3. That's 9. 9 times negative 1 is negative 9. All right, back to our problem. Let's take care of our brackets. We've got this. And then we've got 5 and 1/2 minus. We've got 3 minus 12, which is going to give us negative 9. And then we've got negative 9 plus 2 in the denominator, so that's going to give us negative 7. And then 5 and 1/2 plus 9, we can totally do that. 5 and 1/2 plus 9, that's going to give us 14 and 1/2 all over negative 7. 14 and 1/2 all over negative 7, but that looks kind of bad. We're not supposed to put like we're not supposed to put a fraction over another fraction. So I'm going to change this into a mixed number. You could also just put this in your calculator. You could do 14.5 divided by negative 7. That's fine. Here's another way to do it. So 14 times 2 is 28, plus 1 is 29. I'm actually just going to keep going down. So we're going to get 29 over 2. We keep, we change, we flip. So we will end up with 29 over negative 14. And then that, my friends, is our final answer. If you wanted to, you could also change that into your mixed number. 14 is going to go into 29 twice. So it'd be -2 and 1/14 would be your other answer. Those are your options. We've got 3 more. 3 more to do. How much space do I have here? None. All right, let me come back up here. This is number 6. If you're running out of space like I'm running out of space, you guys should get an extra sheet of paper so it's actually legible and it's not this mess. All right, I'm gonna actually get rid of this and I'm gonna move this number up. All right, number 6. We've got this quantity of 3 cubed plus 3, and it's all over -2 times -3. And then this quantity is squared. Don't miss that. This entire quantity is squared plus a -2 squared all over 3. Okay, let's try this one. Work inside your parentheses first. And inside our parentheses, we can do this piece. And then up in our numerator, let's do this piece. And 3 cubed, 3 times 3 times 3, it's going to give us 27. And we know then that 27 plus 3 is going to give us 30. So I'm going to go ahead and go like this. I know I've got 30 over a positive 6 because -2 times -3 is positive 6. And I'm squaring that. And then watch out, which scenario is this? Is that going to be positive or -4? It should be -4 over 3. And then we've got 30 over 6, which is going to become 5. And then we're cubing that and we're subtracting off 4/3 or 1 1/3, right? So then we've got 25 minus 4/3. If you want to, you could put 25 over 3 if you wanted to. You could do like, well, let's get a common denominator. And so, you know, if we were doing that, we'd multiply by 3, multiply by 3, and that would give us 75 up here. And then we would end up subtracting, sorry, my watch is thinking I'm talking to it. It's distracting me. 75 over 3, and we would subtract off 4/3. So you can do it that way, and then you'd end up with your 71 over 3. Or we keep going and we just say, what's 25 minus 1 1/3? 25 minus 1 is 24. 24 minus 1/3 is 23 2/3. So you can do it that way too. All right, 2 more. I can squeeze it in. Here we go. This one is going to be 3 plus the absolute value of 2 minus 6. And then in the bottom, we are going to have -2 times the absolute value of 3 times 1.5. And then we're subtracting a -3. Let me make sure I'm not missing anything. That looks good. All right, here we go. Let's take care of our grouping symbols. There's one here and one here. So in my numerator, I'm going to have 3 plus the absolute value of -4. In my denominator, I've got -2, and then you're taking 3 times 1 1/2. So think about taking 3 times 1 is 3. What's half of 3? 1 1/2. Add them together. That should be 4.5. If that didn't make sense, you're welcome to use your calculator too. But I was splitting it up. What's 3 times 1 and then 3 times 1/2? Add them together. That should give you your 4 1/2. And then what else am I missing? Oh, I got to add my 3. So minus the negative is going to be +3. All right, let's take care of our absolute values. So let's take care of this piece in here. So we've got the absolute value of -4 is 4. So this is going to be 3 plus 4. In the denominator, the absolute value of 4.5 is just 4.5. So it's going to be -2 times 4.5 plus 3. And then we're ready to multiply, and then we're going to add. and up here we're going to add. So we've got 7 in the numerator. 2 times, then it's going to be -2. -2 times 4.5 is going to give us -9 plus 3. So then we get 7 over -6, or -1 1/6. Ta-da! Okay. Last one, last example. Move this up a little bit. Okay, this one is not going to require too much space. So we've got the quantity of 5 and then an absolute value of, so it's 5 times the absolute value of 2 2/3 minus 5 1/2. Ooh, we're getting tricky. Finish that absolute value, close the parentheses, and we're going to cube it. All right, that's it. So let's do this. Let's work inside here first. We're going to do some subtraction. I'm going to do a little side work over here because I see that I'm going to have to get common denominator, and I'm going to change them into improper fractions. So 3 times 2 is 6, plus 2 is 8. 8 over 3, and I am subtracting 5 times 2 is 10, plus 1 is 11 over 2. Common denominator is going to give me 6. So then times 2, that's going to give me 16, times 3, that's going to give me -33. Make sure I'm doing all my parts and pieces correctly here. Okay. And then I'm going to come up here. We're going to have 5 and then times our absolute value. So let's subtract our 16 minus 33. 16 and 16 is 32. So that'll be -17. -17 over 6. And then I want to make sure I'm not forgetting my pieces here. And then we're going to cube it. So the absolute value of -17 over 6 is +17 over 6, and we are multiplying here. That's another common mistake. Students will just try to add. What operation was happening here from the beginning? It's multiplication. So maybe just write in that symbol so you don't forget to do that. So it's going to be 5 over 1 times 17 over 6. I can't simplify at all, and then I'm cubing it. So here, 5 times 17, so let's see, 5 times 7 is 35, carry the 3, 5 times 1 plus 3 is 8. So we're going to have 85 over 6, and then we're cubing that. So that is the same, by the way. I'm going to come back up here. As us saying 85 times 85 times 85, or we could write it like this, 85 cubed divided by 6 cubed. And then it's divided by 6 times 6 times 6. So I'm going to put that one in my calculator. 85 to the 3rd power is giving me a large number. It's giving me 614,125. 614,125. And then our 6 cubed should end up with 216. Whew, that was a good one. And then we can also, if we want, change it into a mixed number. And that mixed number, if you are changing it into a mixed number, would be, or I'm going to divide my 614,125 divided by 216. That gives me 2,843. 2,843. And let me see, I'm going to change that into a fraction. Oh, that didn't work. With 37 left over. So it's going to be 37 over 216. And that is your final answer. Okay, that's it for this video. Thanks for tuning in, guys.